to Manmaker. I am Ranjan Kumar Kalindi, and today we are going to see previous year question paper of professionally engineer for electronics branch. This paper was held on 17 December 2023. So today we are going to see what kind of question they have asked, what kind of level is there in last year, and we will discuss related to that question only. We are going to discuss some more important point, okay, on the basis of that question only. So today we are going to cover technical part. As you know, total 100 question will be there for your technical round, and for general aptitude only 25 question is there, okay. So first we are going to see technical section. So here we start. So question number 1, okay, from here electronics, for electronics engineer. So first question is what? First question is the number of branches of the root locus is equal to dash of the open loop transfer. Okay. So as we know, like root locus started with the loop poles and end at the zeros. Okay. So if you see the condition, we have two conditions. First is n equal to p when if n equal to p when p is greater than equal to z, okay, and we have n equal to z if p is less than z, okay, where n is what? Where n is number of branches, okay, number of branches. P is what? Number of finite poles, okay, and z is what? Z is number of finite zero, okay. So from here, if you see, if p is greater than equal to z, means number of poles is greater than equal to zeros, then it should be number of poles, number of branches is equal to number of poles. And when p is less than z, when poles is less than number of zero, then number of branches should be equal to number of zero, okay. So from here, the number of branches of the root locus is equal to dash, means n equal to p. It should be number of poles of the open loop transfer function, okay. Now second number, next question will be, so next question is what? Which of the following is correct regard with Fermi level in semiconductor at 0 Kelvin? Okay. So if you see energy band diagram of semiconductor, we have two type of semiconductor. Okay. Semiconductor, we have two type of semiconductor. Intrinsic semiconductor and extrinsic semiconductor, okay, extrinsic semiconductor. So if you see energy band diagram, your energy band diagram will be like this. It will be, okay, this is your valence band and this is your conduction band, okay, and just we will made three diagram. First we will draw this diagram, okay. So this is your valence band, this is your conduction band, this is your conduction band, and this is your valence band, okay. So this is for intrinsic. In intrinsic semiconductor, Fermi level is always in between of conduction band and valence band. This is for intrinsic semiconductor, okay. This is for intrinsic semiconductor. This valence band and conduction band, it is the in between of conduction band and valence band for intrinsic semiconductor. And we have extrinsic, and extrinsic semiconductor means what? We have n type semiconductor and p type semiconductor. Two type of extrinsic semiconductor is there, n type and p type. So if they will ask what is the where Fermi level lie in n type, okay, this is n type. So in n type, Fermi level lie in um, closer to conduction band, okay, and for p type it will be closer to balance band, okay. Like this you have to remember a point, because from any point question will come, okay. So if you see the option, the Fermi level of intrinsic semiconductor lie in the conductor band, so this is wrong. The Fermi level in n-type semiconductor lie closer to valence band. Okay, this is also wrong, because in n-type it will closer to conduction band. Okay, and the Fermi level of p-type semiconductor lie closer to conduction band. This is also wrong, because it will closer to valence band. Okay, and the Fermi level of intrinsic semiconductor lies between conduction band and valence band. So this is right. Okay, option D will be right for this. Okay. Apart from this, you remember this point. From here also, question may they form. Okay. Now, what is the main advantage of double side band suppressed carrier modulation over conventional AM? Okay. So we have generally, if you see amplitude modulation, we have three type of main amplitude modulation is there. First is your DSB-SC, means double sideband suppressed carrier. Second is SSB, means single sideband, and third one is VSB, digital sideband. Okay, so this is what they ask, main advantage of DSB. So if you see main some advantage of DSB-C. Okay, so if you see some advantage of DSB-SC, so first of all, it provide more efficiency. It provide more efficiency compared to other AM modulation, and it has lower power consumption. Lower power consumption. ठीक है? It has lower power consumption, okay, and it provide large bandwidth, okay. This three main advantage is there for DSB-SC. So here if you see option 4, lower power consumption, so this is right for DSB-SC, okay. Sometime question they will ask like why DSB-SC modulation have lower power consumption. So the answer will be this SC, because DSB has suppressed carrier, that's why it has lower power consumption. Okay. So what is the main characteristic that distinguishes white noise from other type of noise? So white noise is what? White noise is random signal. Okay, white noise is random signal, and it always a constant power spectrum density, you can say. Okay, so if you see the diagram, means graphical representation of what noise signal, so it will be, this is n by 2, you can say this is SW. We are representing this thing mathematically, S of W equal to n naught by 2. This is what? This is your noise spectrum density. Okay, so it has constant power spectrum density. Okay, and it contains equal or fixed bandwidth. Also you remember, it contain fixed bandwidth. Okay, it has fixed bandwidth. Like that question also it will come, like in white noise what kind of bandwidth is there, you have to give answer. It has fixed bandwidth. Okay, apart from this they may ask about application. Applications of white noise. Okay, white noise, they may ask application of white noise. So it will help for production of electronics music. Okay, it will uh, means it will help to production for electronic music. It generate impulse response. It generate impulse response, and it is used for frequency response testing. Okay, just remember these points. Okay, if they will ask like this question, frequency response testing means like how they will make question. Means they will give like this following, which are the following application for white noise, and they will give any of this point. You have to tick mark on that one. Okay, so this is about your white noise power spectrum density. Now, in a digital communication scheme, increasing the SNR means signal to noise ratio will be. So SNR is what? SNR is what? Signal to noise ratio. That is signal power divided by noise power. Okay, this is the formula for SNR. And whenever SNR increases, then it will decrease the bit rate error. Okay, this will decrease the bit error rate. That is called BER. Okay, BER. It will decrease BER means bit error rate. Option 2 will be your right answer. Okay. Now the next question, in a two-port network, if Y11 is the short circuit input admittance, then the Y parameter represents. So if you see generally in a two-port network, we have some parameter like Z parameter. Okay, then we have Y parameter. Okay, then we have T parameter, we have H parameter, and we have T parameter, H parameter, and G parameter. Okay, we have this kind of parameter in two-port network. Generally, they will ask question like this: Z parameter. What is the name of Z parameter? So Z parameter is called as open circuit impedance. Okay, this is what open circuit impedance. Y parameter is known as short circuit admittance. Okay, T parameter means what? Transmission parameter. H means hybrid parameter, and G is inverse hybrid parameter. Like this, you have to remember the name. If they will ask in the following which one is open circuit impedance, then you have to give answer Z parameter like this. Okay. Now here they are asking about Y parameter. Okay. So generally, if you see the Y parameter equation, it will be I1 equal to Y11 V1 plus Y12 V2. Okay. And I2 equal to Y21 V1 plus Y22 V2. Okay. Now here as they have written Y11 is what? Y11 is short circuit input admittance. This is admittance. Okay. And they are asking about Y21. And Y21 is what? Y21 is equal to what? This will be I2 by V1. So it is short circuit forward current transfer ratio. Option 2 will be your answer. Okay. Just remember these points for your next exam. Okay. In a closed loop system, what is the primary purpose of integral controller? Okay. So generally we have some we have some parameter in PID that is known as KP, KI and KD. Okay, KP, KI and KD. These are the parameter for PID control. PID, this is PID. Okay, this is P, this is I, and this is D. Generally, we three parameter are there for PID controller. So P, this is what? This is proportional. This is proportional controller. This is integral controller, and this is derivative controller. Okay, so we have three type of controller which are used to reduce, these all are used to reduce the error. Okay, these all are used to reduce error. Okay, and here they ask about ki, that is integral controller, so that is used for to reduce the steady state error, okay, of a controller in a closed loop system. Okay, now what factor does not significantly affect the line of sight communication range? So line of sight communication means LOS. Generally it will affected by your atmospheric condition, antenna height also, and signal frequency, but there will be no effect when modulation scheme will be there. So option 4 will be your right answer. The continuous time Fourier series CTFS of periodic signal can be represented as, so CT continuous means what? Continuous is generally in the term of sine and cosine. So we have this one answer, a series of sine and cosine. It's called continuous time Fourier periodic signal representation. Okay, now the next one, which of the following indicate the operation of BJT in saturation region? Okay, so we have some mode of region. We have mode of region for transistor saturation region. First, we will talk about saturation. Okay, first we will see about saturation. So saturation region. So generally, when it will happen, I will tell you. First, I will tell you this is mode. Okay, this is mode, and we have emitter to bias junction, and then base to collector. Okay, so generally when it is in forward bias and this is also in forward bias, then we can say that transistor is working in saturation region. Okay, when this is in reverse bias and this is also in reverse bias, then this is called cut-off region. Okay, and when it is in forward bias, when it is in reverse bias, then this is what? Active region. Okay, this is what? Active mode or active region. When this is reverse and it is forward bias, then it is called reverse active. Okay, this table is very important because every exam, whatever exam till now happened for BL, they have asked one question from this table. Okay, just remember this table. Apart from this, you need to remember application also. Applications. So when it is in saturation region, then it will work as a on switch. Okay, and when it is in cut-off region, then it will work as a off switch. When it is in active region, then it will used as a amplifier. Okay, amplifier. And when it is in reverse active, then it is used as a attenuator. Okay, these table you have to remember for any exam. Generally question will come from here. If transistor is there, BJT is there, this question will come. Okay, now for condition, for saturation region, this VBE, that is base to emitter voltage, should be greater than equal to 0, or you can say 0.7 volt for silicon and 0.3 for germanium. Okay. Now VBC should be greater than 0, and VCE is less than VBE. Less than VBE means, or VBE less than VBE, or less than VBE. VBE we have what, 0.7. Okay, so less than 0.7, or in the range of 0.1 to 0.3. This is the first condition. Okay, and in this condition, for saturation region, voltage condition is like this, but for the current, IV should be greater than 0 and IC should be greater than 0. This is the saturation region. Now, if you see about active region. So for the active region, this VBE should be greater than 0, or same like 0.7 for silicon and 0.3 for germanium. Okay. Now for VBC, in this case VBC should be less than 0. Okay. And VC is greater than VBE, or you can say greater than 0.2 volt. This is the condition for active region. Okay, this is the condition for active region. Okay, and in this case, IC should be equal to beta IB. Okay, this is for active. Now, if you talk about third, that is your cutoff. Okay, for cutoff region, your VBE should be greater than equal to, less than equal to 0, then VBC also less than 0, and IB, IC, IE all are equal to 0 only. So this is the condition for cutoff. Okay. Now in this question they have asked about saturation region. So in saturation region, VCE should be less than equal to 0.2. Here VCE should be less than VBE, or in the range of 0.1 to 0.3. So this is right. Now IB is greater than 0. Okay. IC is also greater than 0, and VBE, this one is greater than equal to 0.7. So this condition is correct for saturation. Option 3 is your right answer. Okay, so like this you have to remember all the points about from this question. Okay, see, if we are discussing previous year question, that is not means like you just see what kind of question they have asked previously. Apart from this, apart from that, you try to get some more point from that question, and like that question may they ask from the next year, means upcoming exam. So like that you need to prepare for by looking previous year question. So which of the following is necessary condition for Routh array stability? So in this, the main is all the polynomial should be in the positive plane only. Okay, all should be in the positive plane. If anyone is in a negative plane, then the system will be unstable. Okay, so here option A will be right answer. Now, which of the following is the hexadecimal equivalent of octal number 75332? So this is what octal we have given. We have to find hexadecimal. First we need to convert this thing in a binary. So if you see the binary form of 7, so it will be 1 1 1, then 5 will be 1 0 1, 3 we are writing 0 1 1, and 2 we are writing 0 1 0. Like this we are writing for binary. So this is binary representation. Now we have to go for hexadecimal. So for hexadecimal, from this side you have to make 4 4 pair. Okay, 4 4 pair. So this is your 4 4 pair. Okay, so this is 1 0 1 0. 1 0 1 0 is what? 10. 10 we are representing with a. Now this one 0 1 0 1. 0 1 0 1 means what? 5. And 1 1 1 1. 1 1 1 means 15, or that is what? F. Okay, so F. You know, I think this is your answer. Okay, this is 16. Option 4 is a right answer. I think you know this table: 0 0 0 0 0 0 1, 0 0 1 0 0 0 1 1. Like this you need to go for 1 1 1 1. If you know this table, then you can easily solve this type of question. Okay. So now this is over. Now compute the DFT of the following sequence. We have one sequence, we have to find DFT. DFT means what? Discrete Fourier transform we need to find. So we have generally one formula is there for that, x of n. Okay, x of n, or you can say x of k. Okay, x of k is equal to what? Summation of n minus 1, and this one is n equal to 0, x of n e to the power minus j 2 pi by n, and k n. Okay, this is the formula to find DFT. Now here what you need to do, simple things is there. This is x equal to, we have given j, this is 0, this is j, and this is 1 we have. This is called 0 position, this is 1 position, this is 2, and this is 3 position we have. Now this k is what? K, here we need to put k value. K is what? K is here k will be your 0 to n minus 1. So 0 to 1, 2, like this, n minus 1 you need to go. So first you need to put x equal to 0 for 0 position. So if you put here k value 0, then all things are 0. Okay. Then you need to write x of 0 plus x of 1. Same, if you put here k equal to 0, then all thing will be 0, it will come. Then 2, then x is what? 3. Okay. Now x of 0 is what? X of 0 is j. J plus this is 0 plus this is j plus this is 1. So it will be what? We can write 1 plus 2j from here. It will come 1 plus 2j. Like that you have to find for all the condition. Okay. So here the answer will be your option B. Now, what is the characteristic impedance of coaxial transmission line having inner conductor radius of 1 mm, outer conductor radius of 3 mm, dielectric constant equal to a dielectric constant of 9? Okay. So generally characteristic impedance of a coaxial transmission, we have simple formula, that is Z naught. Characteristic impedance is equal to 60 by root under epsilon naught r ln, and ln r2 by r1, r2 by r1. Okay. So here R2 is what? R2 means this is E epsilon naught R. This is what? Your dielectric constant. R2 is your outer radius of outer conductor, and R1 is inner conductor radius. So we have everything. Just we need to put 60 divided by this, we have 9, and this is R2 is how much? 3, and R1 we have 1. Okay. So if you calculate this thing, it will come, this we can write 3, and here you can write 60 by 3, that is equal to 20, and this what? Ln3, the for you will get 1.098. Okay. And if you calculate this, it will come 21.97 ohm. So 4 will be your answer. Okay. Now next question is what? The response of a circuit immediately after the input is suddenly applied is called. So the response circuit immediately after, if we applied in an input, then it is called transient response. Okay. In TDM, what is the purpose of guard time between time slot? So in a TDM means what? Time division multiple access. Generally, we are applying guard time to provide propagation delay difference between the two slots. Okay. So Option C will be right answer to compensate for the propagation delay difference. Okay. Digital communication. What is the primary benefit of using matched filter? So the benefit, if we put matched filter, okay, so we are getting some benefit. What kind of benefit we are getting? The first one is it will reduce inter symbol interface. Okay, it will reduce inter symbol interface, and it will reduce BER. Okay, bit error rate also it will reduce, and it increase data rate. Okay, it increase data rate, and it maximize SNR. Just remember these points for the next question, I means next exam, and all you will get, maybe you will get related to match filter, then like this question they may ask. So from here it reduce the intersymbol interference. This is the right answer. Okay. Transfer of a rectangle function. The Fourier transfer of a rectangle function, if you see the Fourier transfer of rectangle function, generally it is called sinc function. Option D will be your right answer. Okay. Sinc function. Sinc function is known as rectangular function of a for a Fourier transfer. How many satellite signal are required to calculate precise 3D position in GPS? Okay, generally for 3D position we have three cameras. Okay, generally for 3D position we have three cameras to find or measure distance of latitude, longitude, and altitude. Okay, we are using three camera to measure distance of longitude, latitude, and altitude, and one more camera we are using to eliminate error. Okay, so total four camera we are using for satellite. Okay, so like this question is there for your exam. We will cover more question in the next video. Okay, will be there in your exam. Okay, so based on your this previous year paper and syllabus which I discussed before in the class, like in last video, so based on that you can take this practice set of PDF. Here you are going to get same level of question and same all question from all the subject, whatever subject is there in your syllabus. So if you are going to get this, here you are going to get 500 technical question and 125 non-tech question. Okay, just take this one and practice the sets. Apart from that, I will continue the class with some more important questions. Okay, and if you want this one, you can drop a message here. This is my WhatsApp number. Okay, anyhow, my provisionary engineering, you can check this playlist. Here you will get some more important and expected question videos. Okay, just complete that one, and I will bring more question sets in PDF. Okay, so okay, that's all. We'll meet in a next class. Till then, if you like the video, just hit like on a button, kindly share with your friends, and if you not subscribe my channel, subscribe the channel and press bell icon. Thank you.